Joe Gray. I was going to talk about the DFIR capabilities.
Yes.
You gave me about 6 things to mention, all of which I've forgotten, except for maybe social engineer extraordinaire.
Yep, true.
All right.
And just so if you're wondering, I am a licensed state password inspector. I will be doing password inspections in the hallway after the talk, so just make sure to come have them. I'll check them against code. It'll be totally fine. So welcome to Dear Blue Team. These are forensic ideas to help do better incident response from the eyes of someone who does forensics. Before we get started, the thoughts and opinions I express are mine and not my employer, IBM's. So about me, I'm a senior security architect at IBM. I've been a sysadmin, I've been a security engineer, I've been a consultant. I am the 2017 DerbyCon Social Engineering Capture the Flag winner. Not that that's relevant to this, but I use this slide on every presentation, so I apologize. We all plagiarize. I write blogs, I do my own podcast and blog, Advanced Persistent Security, and I tap out a lot in Brazilian Jiu-Jitsu. So, with that being said, why this topic in this talk? So basically, I took SANS Forensics 508, the Advanced Incident Response, Digital Forensics and Threat Hunting course. It goes with the GCFA certification. I waited too long now. I'm actually going to have to pay almost $2,000 to take it, but I'll do it one day. But the academic in me was reflecting upon what I had learned in the course. And it's like, why are we not doing this proactively? That's a good question. So basically, this is the product of those thoughts. So we got a little bit of the standard digital forensics and incident response talk that I'm just going to put out so we're all on the same wavelength. So basically, DFIR is digital forensics and incident response. Digital forensics is basically the science behind reconstructing what happened. It's just like other forensics, like crime scene forensics. It's the same concept, it's just you're doing it within the confines of a computer system. You may also hear it referred to as computer forensics or network forensics and what have you. There are varying types, and this one actually is going to focus a lot on memory forensics. But anyway, a few other terms that we kind of have to look at would be incident handling versus incident response. So basically, from the definition that I got from SANS Internet Storm Center, would be the incident response would be the technical piece of how you handle an adverse event, which that's what an incident is, an adverse event. Incident handling brings in other things like the business aspect of it, the logistics, the finance, the communications, how to actually extinguish your C-level executive's hair from being on fire. Because let's face it, that's what happens. And then here we have the process, commonly referred to as pie curl. I promise I'm going to change the colors of that one day. I just haven't gotten around to it. But the process is preparation, identification, containment, eradication, recovery, lessons learned. You might hear it referred to as pie curl. So another thing that we hear about a lot is threat intelligence. What is that? That's a good question. But basically, it's just the act of understanding specific behaviors or atomic pieces of information such as an IP address, a mutex, a hash, something that tells you, hey, this has been associated with this. For example, to put this into terms for law enforcement, if you see a car doing 75 miles an hour in a place with a speed limit of 45, your indicators of compromise will tell you that that car is speeding and you should probably pull them over to make some revenue, right? I have a lead foot, I apologize. But with that, how does this play into the DFIR process? Is one a product of the other, or is it both ways? So they're not the same. Threat intelligence plays into your incident response. It plays into your incident detection. When you have those IDS signatures, or you put things through a SIM that has a threat intelligence feed, like for example, Alien Vault's USM or OSIM with the OTX feed coming in it. If something comes in that matches that, you're going to get an alarm that will trigger your incident response process. So that kind of answers that last bullet of, does threat intelligence trigger incident response, or does incident response produce threat intelligence? Which is it? Both, exactly. Because part of your recovery, part of your lessons learned during an incident response engagement is to produce actionable threat intelligence that you can gather from what happened. There may be nothing new. It may be identical to something else. There may be something no one's seen before that could be the next big thing as well. So when we talk about the types of forensics, when I took the class initially, I was looking forward to doing nothing but sleuth kit, scalpel, all the fun stuff with the file systems. The course doesn't really focus too much on that. It's actually heavier in memory forensics. And in hindsight, I understand why, but understanding that there's that type of forensics, you have your memory forensics, and then you have your network forensics. That one's where you're going to play with like TCP dump, Wireshark, and if you're really lazy or under a time constraint, network miner. But with that being said, if you want to do this, you could play with various operating systems. So SIFT, the SANS Investigative Forensic Toolkit, is probably your first and foremost to go with. There's also Remnux for reverse engineering malware. But the thing is, you can actually install SIFT on top of Remnux or Remnux on top of SIFT. There's another one that's not a SANS product called CANE, the Computer Aided Investigative Network Environment. It's very similar. I've not played with it, but I know of its existence. To some degree, Kali does it. They have some memory tools in it. They have a few forensics tools, but that's more for getting a memory image and running Mimikatz against that memory image so that you can gain access during a pen test. That's not to go off and get indicators of compromise. Sure, you could do that, but it's probably not the most efficient way. And then there used to be a thing called Mercenary Linux. Because I've not heard back, I'm going to strike this from any future presentation of this, but it used to be a distribution of Linux solely for threat hunting, which I'm sorry if you came thinking this was a threat hunting talk, but this is the proactive forensics that is not threat hunting, and I'll explain that part right now, actually. So threat hunting, it's became a vendor buzzword. Those who know me know I absolutely despise vendor buzzwords. I scoff at them. They make me sick. And that message was powered by blockchain and AI and machine learning, and we can go on from there. But anyway, so with it, it's a very popular buzzword, and a lot of companies are claiming to do it. I'm not going to say who is and who isn't because I don't really care with the vendors. That's something that management for each organization has to make the intelligent decision. I'm not going to get on a soapbox and tell you what's right for your environment, period. But anyway, tools and techniques of threat hunting. Very simply, you know what they are? The exact same that you're going to use for forensics. If you really want to summarize threat hunting into a far less sexier term, it is digital forensics before something happens. You're doing forensic techniques on your systems to try to find things before they manifest and snowball. So it's just another effort in the identification phase of incident response. Benefits, of course. You can cut things off at the pass. You don't have to worry about things going widespread. You can identify advanced or malicious actors during their dwell time. So there's another buzzword that it cuts down, dwell time. That's what's dwell time these days? I know one vendor said it was like 867,530.9 days. One said it was 90, some said 280. It really doesn't matter. You're just trying to cut dwell time. You're trying to find them before they're able to do something. I was having a conversation with Adrian Sanabria on my podcast a few weeks ago. He was talking about his RSA, it's time to kill the pen test talk, which basically talks about we need to do red teaming. But we were talking about dwell time, and he's like, honestly, I'm not a fan of black box pen testing. I think, and this is Adrian speaking, he is a fan of white box. And I was like, you know, the light bulb just went off because when we talk about dwell time, during that time frame, an adversary basically can turn their black box unauthorized pen test, the one that's going to get the report written by Brian Krebs, they can turn it into a white box during that amount of time. They can understand what is normal in your environment. That's what really helps with the threat hunting. You're able to cut that out. You can find that malicious SVC host or that weird PSExec process or something that's going on. But I have to tell you, with threat hunting, it's not for everyone. There's a certain level of maturity associated with it. If you don't have a robust incident response plan, you probably have very little business doing threat hunting. Because what are you going to do when you find something? If you have a very immature or weak incident response plan, great, you found it. What are you going to do with it? You don't know. So there's a certain level of maturity. So here's basically the two side by side. So digital forensics is reactive in nature. Threat hunting is proactive. There are very few prerequisites for forensics. Typically, it's an adverse event that requires you to find something out, or someone deleting files before they leave a job. That's typically what it is. And you might find out via monitoring something weird, website defacement. The FBI might knock on your door and say, hey, something's going on. The social engineer in me says you might get a call from the Microsofts telling you that there's all these malwares trying to infect their system. Purely kidding there. But anyway, we want to find out everything we can. The forensics people, we want to find out whatever we can. And the business says, no, find out what you need to know to get us back up and running in a quick and efficient manner at the lowest cost possible without having to go very public. So there's that dichotomy, but at the end of the day, with forensics, we're trying to restore things and get it back up and running quickly because time is money. Well, with threat hunting, it's all based around what is normal. And this is one of those instances where I say you might not want to hire a consultant to come in and threat hunt for you because you're going to pay for like a 24 or 48-hour engagement. How well do you think that engagement's going to go in terms of them understanding what is normal in your environment with 24 or 48 hours of consulting hours? Not very much. Not when you consider what dwell time is. Not when you consider if you have an internal team that already knows what is normal. That's where the benefit comes. You're going to try to consume that threat intelligence. You're going to have specific indicators you're looking for in each hunt engagement. You're looking for anomalies. It's not based on a time objective within reason. You can't spend the rest of your life searching for something from APT 29, right? You can't. Do it for a set amount of time, move on to something else. And that's why the whole consulting thing really doesn't pan out, because sometimes it's low and slow. But anyway, let's go ahead and do the standard, the absolute standard, single slide forensics talk. Log everything, do it verbose. You might want to do remote logging to another host so that when someone comes in and tries to do anti-forensics and executes that script that's just going to fill up your file within whatever you've got configured within Windows, or rotate it, that's fine. You're going to notice that too, because those logs are being sent somewhere else, preferably offsite and or in the cloud. And the cloud's probably your best bet, as long as it's not in a leaky bucket. Let's face it, logs will make you or break you. They're not the end-all be-all. You can find out a lot of things using file system or memory forensics, but you need to be able to corroborate it with logs. You might find something that isn't logged, or you might find a log entry that corresponds to a memory event that you can actually create alerts in your SIM to help you do it faster next time. We always hear inventory everything, and I'm going to talk more about the whole inventory, baseline, all that fun stuff, but you really need to know what's going on. The first and second, I still call it the SANS top 20, but critical security controls have an inventory of authorized and unauthorized hardware and software. That's number one and number two. Back to that whole maturity model, right? A lot of times, we're like, what should that consist of? Well, I have Firefox, Chrome, Flash, Java, all this installed. Okay, cool. We'll get a little bit more into that in a bit. Just let that percolate for a moment. If you're in a Windows environment, if you want to get a verbose inventory, there's a PowerShell tool called Consa that you can actually execute. It will interrogate the host using WMI and collect the data, put it into a flat file for you. You could parse that into whatever you would like. And because it's open source, it's for the ripe price of free 50. So you need some sort of network time. If you're in a local place, like if you have one single location, you might not need the NTP. You could use time.microsoft, whatever. If you've got sites across several countries or time zones, you need to have one central time location in the same time zone, and you probably want to have an internal NTP server for that, because the last thing you want to do is try to correlate events and have to be counting on your fingers and your toes to figure out what time it happened there, as opposed to what time it happened here. Baselines, that's really what this talk is about, and we'll get into that in just a moment. So here's one of the soft skills things. Oftentimes with the incident response process, we're like, okay, well, notify security, we'll take care of it. Okay, great. I see a gate guard. I'm like, hey, I got a piece of malware on my computer. The gate guard is in security, in physical security. But that's what the plan says, notify security. Okay, how about this? Here's who we notify. Here's a phone number, here's an email address, you can text this, here's a Signal username or Wicker, whatever you want to use. Here's a Slack channel. Send your carrier pigeons, your smoke signals, your Morse code, Campbell soup cans on a string. How do you want them to notify? Do you want it to be via phone, via email, in person, text? Okay, cool. Well, I'll give you a hint. If someone's clicked to fish, you probably don't want to do it via email because I would just go ahead and assume that that's compromised. Whether it is or it isn't, it's a good assumption because that could actually make your incident response process harder as well. If you're using email for your communications, if the attacker's in there, they're going to read all the email and they're going to say, oh, well, here's what they're about to do. Audible, let's change it. So that's something definitely to consider. What actions do you want the user to take? The vast majority of our companies are not security professionals. As security professionals, we need to stop trying to make them be security professionals. Make the decisions for them, communicate the decisions ahead of time, and deal with inefficiencies with those decisions later. I always think of things like, what action do we take? Okay, my mom's nearing 60. She's not very technical most of the time. And, okay. Mom, unplug the network cable from the back of your computer. Every single cable is going to get unplugged, if any. It's going to be all or none. Okay? So what if you use the same color networking cable throughout your entire organization? Hey, unplug the yellow cable. If I told my mom that, she could do it. If they're not comfortable doing that, give them a pair of scissors. They're not going to get shocked. It's not going to hurt them. You can get a new cable. It's okay. Cable's not that expensive in the grand scheme of things. But what should we not do? We have to respect the chain of custody. So if you have a compromised user account, disable it. Don't change the password. Changing the password could give someone an out in court because at the end of the day, we're looking at this from the perspective of what happens when this goes to court for litigation. We're in a very litigious society. It's bound to happen. This one's from a real life scenario. When someone attacks you with fileless ransomware, and it got there because you had an instance, an outdated instance, on a Microsoft 2003 VM of RDP running on the public internet, logging in as admin with the 4-character password, I know. I got Forrest Whitaker eye. It was bad. It was really bad. And I drive an hour and a half to your location to do the incident response, and I'm like, all right, let me see the logs, let me see the system. Oh, I deleted the VM. It's probably not an action you want to take, unless you're trying to hide something. But nevertheless, understand how what you're doing is going to affect and preserve your environment. That's the most important thing. And the chain of custody, I mean, say what you will about the OJ case. I really have no opinion. I was way young when that happened. But I did watch the whole thing on that channel when they did the whole OJ trial, where they had Dave Schwimmer play the Kardashians' dad. I remember that. And what I picked up from that is they didn't maintain and respect the chain of custody. Had they done that, the outcome may have been different. Win, lose, or draw, I'm not going to get into that. So let's talk about the cool stuff. So, memory analysis. How do we acquire memory? There's a lot of ways we can do it. There's agents. This is not an all-inclusive list. You can use FTK Imager. If you do things like I do on a budget, I don't like to pay for things. So I don't go and get bogus licenses. I just use free stuff. FTK Imager Lite is free $99. You can use Google Rapid Response, GR. It's an agent that sits on every system that's got recall built into it, so you can actually do the memory analysis live. And then you've got other things like XPMEM, DD, F-Response if you're looking to pay for something. Mandiant Intelligent Response does it as well. You've got your assessment tools, which I mentioned recall, but then there's also volatility, which my understanding is, doesn't volatility have a lot of ties to this community, like the New Orleans location?
In your case, is one of local people here.
The exact reason I said it. That's the exact reason why I didn't submit a social engineering talk for this conference. Because I figured it's NOLA, so there's a good chance forensics would be better. But anyway, so volatility and recall came from the same source. They split. Recall is maintained by someone at Google right now. Volatility is here in NOLA. Redline, it's a GUI. I'll tell you, if you're going to use it, use a version. I use version 1.14. I don't typically use outdated software, but they did away with probably the most valuable tool in this package with version 1.20. And it's called the MRI, the Malware Risk Index. With the GUI solution with Redline, you're not trying to find out exactly what's happening, you're just getting hints. It's the 30,000-foot view before you go digging to the core of the earth with volatility. But anyway, so basically, what are we trying to do? We're trying to find out what's running on the system, what's executed, what may have not written to a log yet, what may not be on the file system yet. Find evidence outside syslog. Those of you doing malware analysis that use sysinternals, this can replace a lot of that. Detonate it, pause it, take the memory image, analyze it. It'll work almost the same. You can use it in cross-reference. Never trust one single source. In the Navy, we had a term called trust but verify. Use this for verification. You can always assess processes, right? You can take a look at them. You can even carve them out and upload them to VirusTotal. Then you can find out what's going on here. Windows registry analysis. And then there's a few plugins built to actually assess malware. Basically, that's going to be based on certain logic checks to say, this may be malicious, this may not be. Take a closer look at it. So, what are some of the capabilities? We can dump passwords. Like I said, I mentioned in Kali that you could use it for Mimikatz. You can do that anywhere. There's a Mimikatz plugin for volatility. You can dump hashes. That's always a good idea. Rogue processes. That whole sysinternals thing, that second bullet, PS total, PS scan, PS list, PS tree, that will actually do a lot of that for you. PS total, my understanding is that one you can only get from the SANS GitHub, or if you take a SANS course and get that version of SIFT, supposedly it's some secret sauce. What it does is it correlates the other three plugins into a dot file that you can convert into an image file and take a look at. That's basically all it does. And it color codes things so it makes it easier to hone in on things to take a closer look at. We can look at the networking. And I've got 3 plugins here mentioned, but NetScan's the one we're going to use with anything after XP. DLLs, carve processes. You can even find the registry key creation date. And taking from Rob Lee, the SANS instructor for the course, he basically called this truth. And he said there's speculation that some advanced adversaries out there can edit your registry key creation date, but if they're in your network, you're probably not going to know it anyway. It's all good. But for the most part, if you know a specific registry key, you can actually query that in a volatility plugin and find out, hey, this is when we do it. You can build a timeline, and then there's your memory analysis once there. So other things. There's a thing called prefetch. This is outside of volatility, but basically you can use prefetch parser, and you can find things that's going on. And basically what it is it's supposed to help you load applications faster by checking a few things within the system in terms of compatibility. A lack of prefetch, it could be suspicious, or it might not be. It's not configured by default. If you want to check if you've got prefetch on your system, there's the path in blue. Another one, the shim cache, also known as the application compatibility cache. It's going to check the compatibility of applications. You're going to find out when it was ran the first time and every time subsequently after that. You're going to find out things like the full path, standard information, process execution flag, all sorts of stuff. Again, this is another gold mine. So, what about the processes? How many times do we see SVC host running, but it's malicious? I mean, SVC host should always be running with the -K switch, right? And it should always be running from system 32. What happens when it's running from a subordinate directory of system 32 without that switch? It's probably Trojan. I wish I had a hash to compare it against. So why not take a hash of things in system 32, specifically things like SVC host? Some of your magic jewels of your organization, your crown jewels. Have that periodically. You can script that. You can do it with the for statement. For I in files, you define the files, you have the list right there. For I in files, hash all of these. Write it to a file. It's not that hard. You can do it in batch, you can do it in bash, you can do it in PowerShell, Python, whatever you want. There's various ways to do it. Write it to a file, okay? So this doesn't match, okay? Another thing you could do aside from the MD5 hash, which is going to be very binary, does this match or does it not? You can do what is called fuzzy hashing, which is byte by byte hashing using SSDeep. So within this imaginary code, we have the for I in files do hash. If hash does not match, verify against the fuzzy hash. If that matches, you've got some sort of anomaly. If it doesn't match, which we don't expect it to, you can look at the byte by byte differences and see what exactly changed. Because all comparing two SSDeeps it's basically a file diff. It's going to help you hone in on what's going on. With the registry, look at your registry key creation dates, especially of certain hives that may be commonly misused. Get a hash of your registry. Understand when it's modified. Not everything that's going to execute on your system is going to make a registry key entry. But when it changes, you want to know about it. You can always use regular expressions for things. I'm a huge fan of them. It's never a bad idea to use them. So back to the baseline thing. What is a baseline? What consists of a baseline? When I worked in the DoD, a baseline was, here's your hardware list, here's your IP address, here's your MAC, here's the installed software, and if you were lucky and had a proactive system administrator, you knew which versions. For the most part, you didn't find out versions. Cool. Not saying that you don't need to do that, because you should, but there's more to it than that. Which versions? What's the hash? The hash should be part of your baseline. This is a time that you should have a golden image for your organization. And I'm going to help you take it a step further too. Sorry for using the DoD terminology with the golden image, but I mean, if it's not broke, then why fix it? So you have a standard image for your organization. This is the baseline image for Acme Corp. Okay, cool. HR requests all of this fancy software. IT requires all this software. Okay, cool. So here's an overlay for IT. Here's an overlay for HR. Here's one for accounting. Here's one for executives. So now you have essentially 5 standard images. 6, whatever. Why not execute these images and take a memory capture? So why is that important? Okay. So Joe decides he's going to do a vishing expedition against your CFO. He's going to call and say he's with legal and he needs your help to click something, and he sends you everything and you do. And then you email back and say the link doesn't work after you clicked it 15 times. So he sends you a macro-enabled Word doc. You click it twice. Okay. That doesn't work either. So finally he just gives up and sends you an executable and takes over your system. Bam, incident created. Not that that ever happened when I was doing social engineering in my last job against a financial institution. Never. Nor did we ever get domain admin on that either. But anyway, when that happens, we need to do memory forensics. What is normal? What do we compare it against? Well, he was the CFO. Let's go get the CEO's laptop. No, that's probably not a good idea. If I've learned anything during social engineering, it is the C-level, their systems, quite honestly, are terrible. And if you can get them on the phone, they trust anybody if you can make it through their assistant. They're the best targets ever. I'm surprised there's not more whaling in the world, but maybe one day. Maybe we can go, I'll go ahead and coin a term. We'll just call it spear whaling. We'll call it that later. Anyway, we do this. Okay, well here are 3 volatility plugins that you can actually use to compare the known running processes, the known running servers, or services, and drivers. Instead of having to go get a possibly infected machine to compare that against, you have a clean image from the get-go that you built, you created, you verified. You've got a chain of custody for it, so you know it is secure. Compare the two. What's different? May not be anything of value. Might be something worth looking at. One or the other. So you could do it of every single host, and like I said, I work at IBM. It's At any given time, we have between 300,000 and 500,000 employees. It's not very practical for us to take a memory image of every single computer within the organization, especially when you factor in that there's the soft layer cloud offering. So that's just not practical. If you're a small organization, 2 to 3 hosts, maybe even up to 10, do it. Go for it. But here's what you got to factor in. You've got to verify that the system is clean when you do it and it doesn't already have a few malicious actors in it. And secondly, storage is money. In this industry, 3 things equate to money: storage, processing power, and time. You'll need some processing power. You can script it for time, but you still have to have a place to store it. I know cloud providers like AWS, Azure, Google, SoftLayer, whomever else, they would love for me to tell you you need to do it on every single host. They would be more than willing to help you find a solution to meet your needs. But understand what your tolerance for it is. Understand your budget. So, very briefly on network forensics, this is some low-hanging fruit as well. You should take your PCAPs as often as possible. If you have the capability of have a constant running PCAP, go for it. Again, storage is money. Do some SIM integration. NetFlow, it's good metadata. It's not going to tell you everything that happened, but it's going to tell you enough to where you have some context around it. You can know which host communicated with which host. You can look at the bytes and packets sent, understand how big they are. Is this something where they probably exfiltrated some data? Maybe, maybe not. Did they just transfer something in? Okay, what was it? Vulnerability data. I mean, let's just be real. Most of the time we wouldn't be having incidents if we had better vulnerability management. But that horse has long been beaten, and I really have no desire to beat a horse with a baseball bat today. My arms are a little sore from flying in yesterday. So if you want to carve PCAPs, there's a few ways you can go about it. You could use Wireshark and do your regular expressions, go digging and things. Or, like I said, you can be lazy. And I say you can be lazy because I was like, hey, Marcel, I'm friends with Marcel Lee. I was like, hey, have you seen this like PCAP utility called Network Miner? She's like, yeah, I've seen it. Are you using it? Yeah. You're lazy. She's a Wireshark purist. But with that being said, though, when you're consulting and you don't have a whole lot of time or you're trying to do things very efficiently to move on, that can give you a quick look. That's kind of like red line to volatility, if you will. So it's just something worth taking a look at. So in the remaining 20 minutes, I have made my sacrifices to the demo gods for those of you who were in here earlier. Let me get back to the extension for a second. I've got to get a file ready. So we're just going to walk through a few demo type things. Waiting for that to, there it is. So I'm just going to show you very quickly about a memory capture using FTK Imager Lite. I'm not saying you have to use this, but it's my favorite price, so that's why I'm going this route. It's very easy. If you want to do a full disk image, you can do that here. Or you can just capture memory here, give it a destination path. Keep in mind, this is an executable. You don't have to install anything. So you can have this on a thumb drive or external hard drive and actually capture to that same device. It doesn't have to be to the local hard drive. You can also include the page file and an AD1 file if you want to go that route. You set everything up, you say capture, and you're off to the races. If you're dealing with a system with 8 gigs of RAM, you're going to need 8 gigs of storage. So that's why the thumb rule is anytime you're capturing something, you should always have 125% of what you need. So if you're going 8 gigs, you need 10 gigs of storage just to be safe, because not all 8 are going to be usable anyway. So we have that angle. Let's take a quick look at let's look at some packets. Oh, sorry. Let me go back to duplicate. Did you see the capture? Did that duplicate or did you not see it? You didn't see the capture? Okay, we'll go back to that then. Sorry, I thought I had it on duplicate. So, okay, here's Network Miner. We're just going to open a PCAP here. We'll look at that one in a moment. So at the bottom here of the system, you can see that I have PuTTY on the system, but PuTTY is not running, correct? We see this? So I'm just loading this PCAP, where it was supposed to load. Yep, there it goes. So here we're able to see, and I apologize I can't zoom in with this, but here we're able to see the IP address, the MAC address, some system data. We can look at the sessions, sent, received, all that. Here's some session data as well, so we see it was over NetBIOS, no big deal. But right here we find a file. With this we can calculate the hash. So there's your MD5, your SHA-1, SHA-256, etc. If we want to, say, upload this into VirusTotal and see what's going on, well, right there, we've got the file path. We can copy and paste that or drag and drop it into VirusTotal. Or, if this were malware, I wouldn't be doing this, but I'll go ahead and do it with this. Oh, look, I just opened PuTTY. So it executed it. It actually carved this out. It looked for the header and the footer of the file, and basically it said, this is an executable, and its file name is putty.exe. So that's one example. I'm going to clear the GUI, and we're going to look at magnitude. So with this, I just went online, I downloaded this. I think I got it from Contagio Dump, I'm not sure. But I went looking for a lot of stuff, and we can see there's a lot of stuff going on here, and this is from a malvertising campaign. So the specific context of this PCAP is it's based on malvertising to try to deploy the magnitude exploit kit. It's still got some stuff going, so let's see. Okay, all this stuff's up, good. So we're gonna have a look around. So I'm gonna add a little threat intelligence to today so that we have a few more tokens in the buzzword bingo game if you want to play that game. So we're still waiting on this. As we can see here, there's the word SERB, so I'll give you a hint, it deals with server ransomware. There's a boatload of data for it. All right, so we have over 8,000 parameters. So we can look here, we see things like right there's a URL, 200 code. We can look at all sorts of things and just dig however you want. You can have keywords here, so we'll just look at HTTP, I suppose. Well, that was probably a bad choice. Anyway, we can take a look at sessions. Here are all the various sessions. We can find some credentials sometimes. They may be what we're looking for, they may not be. It may just be a string that this thinks is a credential. Here are some images we can look at. What's going on here? There's a lot of Pokemon. This must have been on a gamer site of some sort. But anyway, here are files. We won't acknowledge PuTTY because it just didn't clear out. So I always look at it from the largest to the smallest. Understanding that just because it's a large file doesn't mean it's malicious, but it's a good place to start. So here at the bottom, we have an HTML file with like 650 meg. So let's take a look at the hash. We'll copy and paste the MD5. We might get something out of this, we might not. So we're just going to go over and we're going to play with some threat intelligence here. So we've got a hash. We'll put it here, okay. In the meantime, we're also going to search in Alien Vault OTX. Okay, well, if I have to log back in, I'm just going to close that window. Check threat miner. And we'll reload threat crowd and come back to that in a moment. So here, I created this threat intelligence feed that we're about to see, that you see in the background. That's my cartoon avatar, but that's just an example of if you have something, you can go searching for it. Here in VirusTotal, I didn't create this stuff, but it's there. So we can see the information as it's related to everything. So we see which antivirus vendors pick it up and which don't. So it's a good indication of who you might want to do business with and who you may not want to do business with. So in this case, ClamAV is probably the most well-known that didn't see anything. In some cases, only 2 or 3 see it. We could take a look at some details. So we have the hashes here. We could take a look at that. There's the SS deep for it even, if you'd like to go that route. We can look at the relationships with other sites. I'm not logged in, so I can't go looking at things, but there's ipinfo.io. You can find out which IP addresses that's associated with, who owns them, and other pieces of information about that. Oh, it looks like I'm in. We'll see. Anyway, Threat Miner is a good one as well because it actually aggregates from several sites to include things like Virus Total, Hybrid Analysis, Threat Expert, Malware, Virus Share, Threat Crowd, OTX. There are others. Risk IQ is in there as well. So it aggregates across all these, and it's not the one and only threat intelligence feed, but for me, I'm about efficiency and I'm about cheap. So this is free, and it gives you an idea of where to go looking elsewhere. If you're looking for nation state actors, you may find it here. You may not. You may have to go looking in something you might have to pay for. Just understand it's not the end all be all. Threat Crowd has a very similar interface. We'll see if we see anything. Nothing's loading here, so I'll just close that out. No big deal. So it's searching. So with Virus Total, let's go back here. So we have the file. We'll take a look at this one right here. Let's open the folder. So we'll just cut that. Go back to Virus Total. Go for a file. It's going to say choose file. Right there it is. It starts with the 6. I do recall that. We upload it. If it uploads, there it goes. Same thing. So you can do the hash or upload the file. Keep in mind though, this may not be the best answer. And the reason I say that is if you're chasing a persistent threat, an advanced adversary, uploading into this may blow your cover and you may lose what you're looking for. So consult your organization, policy, procedures, and management discretion before you start uploading things to Virus Total. Make sure someone else agrees to do it before you just go off doing it. And it's not just Virus Total, it's any website of the sort. So going away from that and going away from the network side, let's take a look at some stuff. So this is the SIFT Linux VM. While it's doing its thing, let's open a previous analysis. Actually, we'll just take a look at this in Romanoff one, see what's going on. Anybody know Natasha Romanoff? I'm not too up to speed on like comic books and pop culture, so I totally didn't get it in the beginning. So anyway, so we'll open this session while that's doing its thing. Whoa. Give us a moment to finish loading as well. Looks like we're good on time as well. I'm a bit impatient from time to time. There we go. So we're just going to take a look at it from the full live response. Just wait for it to load. There it goes. So as soon as this finishes loading, there we go. We see right here the MRI, right where my cursor is. Oh, there's a red one. In version 1.20 or later, that's gone. To me, this is the most useful thing about it. So here we can take a look at it. We say, let's show details. So here we can say, oh, it's SVC host, but its parent is PS exec. The path is system32/DLL host. That probably is not that's not the SVC host you're looking for. So we see this. There's the security identifier of who ran it, so you can go back through the registry and see that. Oh, there's a duplicate. Now we have a PID, so if we want to go searching for things by PID, we can actually isolate that, which we'll just keep in mind 6404 for later. Any networking events? In this case, it didn't communicate with anything. But let's look at this from the hierarchy perspective. So now we know this is malicious. We know its PID is 6404. So let's take a look at things related to that. Okay, so we see right here that its parent process is PSExec PID 2100. That spawned spinlock.exe that also spawned spinlock.exe. But in addition to spawning the first spinlock, PSExec also spawned SVC host. Okay. So immediately in your notepad for what you're going to analyze later, I would be taking down PID 2100, 2956, 1328, and 6404. Okay, let's see what else we can see here. Nothing interesting here. Let's see what the details of PS exec say. This might tell us which host it came from, which could be important. Doesn't look like it's going to, though. Sometimes you win, sometimes you lose. The ports, if it's beaconing out or anything of the sort, we should see that here as well. Again, this is the 30,000 foot view. You're not trying to dig to the center of the earth with this. You're just trying to get an understanding of what we would call the pivot point. So here we have SIFT. I've got the command line open. So we're going to go into the cases directory. So here we see that we have the C drive, the incident response, and the memory. We're going to look at the memory. So here we have a lot of stuff. I've ran a lot of analysis on this myself, so there's a lot of stuff here. So like for example, malfind, this is the output of the volatility malfind plugin. So basically it just goes through. We can even go as far as to grep for certain strings that we're looking for. Like for example, we know that the header of executables, specifically portable executables, is MZ, Mike Zulu. You could actually grep for that. Oh, and look, it's PID 6404. Shocker, right? So this is just one example. So let's see here. Volatility.py. Profile equals when. Just got to give it this because I haven't exported the specific profile. So we've kicked this off. Let's see if Mimikatz finds anything. It's thinking. I'll go ahead and close redline. So for some of these things, they'll find it very quickly. Some, it takes a long time. I found that specifically Mimikatz is not one that takes a very long time. There's a few that I ran for 3 straight days and they still never finished. So it probably just means that I need more money via processing power. And there are the credentials for this. So we can see that N Romanoff is Black Widow, T Dungan is Bang Dum Dum Bang, Vibranium is Hail Hydra, our Sideow is This is an Actual Passphrase. So there's a lot going on there with it. The last one I will do will be NetScan. This is basically the equivalent of netstat minus AN. So right here we're seeing things that's coming up. This is what was executing at the time of the execution. Okay, that's going to take a moment, so let me go back here. So I'll go ahead and finish the presentation, and then if it's done by the time we're done, just a shout out to Adrian Sanabria. He couldn't be here. He's at B-Sides Knox Hill today, but he can see clearly now the rain is gone. The context behind this was he was actually holding an owl in his hand, and we cropped the owl out. And he's the official mascot of the Knoxville DEF CON group, DC865. So you may see that trending on Twitter today. We bought like 500 stickers with this face on it to give out at B-Sides. Who says InfoSec people aren't trolls? So as I close up, I just want to bring a little attention to my mentorship project called Through the Hacking Glass. It's in partnership with Peerlist. Basically, we want to be the gap between academia and certification. A lot of people are like, hey, I've got Security Plus, I've got a bachelor's. What do I do? How do I get this? So we're pairing people with mentors or pairing people with mentees as appropriate to help you learn the skills associated with the attack phase, the hardening phase, monitoring, incident response, and analysis. If you want to know more information, you can follow us on Twitter at HackingGlass. There's the rest of the contact information. We're hoping to pair the mentors and mentees in June. and have the first level, because we're having 5 levels of complexity and difficulty. We're hoping to have all the curriculum for level 1 done in time for Hacker Summer Camp. Here's my upcoming speaking engagements. So in 2 weeks, I'll be at Circle City Con, then at the National Cyber Summit. The reason that SERI is in bold is I'm teaching a 1-day social engineering and OSINT workshop there, and then speaking the next day. I am competing in the DEF CON Social Engineering Capture the Flag. I've got a few new tricks up my sleeve that I'm looking forward to bringing out to the public. I'm staying very quiet about them until then. Hacker Halted, Cybersecurity Atlanta. On the topic of Hacker Halted, if you want free admission to Hacker Halted, here's the coupon code. I have as many of them as can be consumed. If you want to go or you want to share it with your friends, your colleagues, whomever else, even your postal carrier if you would like, there's the coupon code. You can also get 25% off the training as well. It's September 13th and 14th in Atlanta. So if you're local to here, it's a short flight. I'd say probably a longer drive than you'd want to take, but it'll be fun. I think the keynotes are about to be announced. For what I know, they're pretty big. There's quite a few very solid names speaking as well. That's not been announced yet either, but I'm slightly privy to the information. Any questions? Questions, comments, concerns, complaints, grievances, anything of the sort? All right, thank you very much. Oh, and if you